So, the second to the last topic sa derivative of function, the hyperbolic function. So, hyperbolic function class is, ito yung 6 trigonometric function, pero nadagdagan lang siya ng variable na h. So, the hyperbolic sine function, denoted by sine h. Okay, hyperbolic sine function, denoted by sine h. And the hyperbolic cosine function, denoted by cosine h. Kaya naging h, may h dyan kasi hyperbolic siya, are given by, for all real numbers x. So, sine h or hyperbolic sine x is equal to 1/2 times e to the power of x minus e to the power of negative x, and cosine h of x or the hyperbolic cosine function x is equal to 1/2 times e to the power of x plus e to the power of negative x. So, the same lang sila ng formula, but hyperbolic sine function is negative or minus. The hyperbolic cosine function naman is plus. And hence, the identity cosine squared h of x minus sine squared h of x equals to 1. So, diba sa trigonometric function or trigonometric identity na cosine squared of x minus sine squared of x equals to 1. So, saya kasi ninumanan mo sa variable h kasi na hyperbolic. So, naman is ganyan. The analogy between trigonometric functions and hyperbolic functions. So, sa tangent of h of x or the hyperbolic tangent function of x is equal to sine over cosine. The hyperbolic cotangent of x is equal to the cosine or hyperbolic cosine of x divided by the hyperbolic sine of x. Okay. So, kumaga na, trigonometric function na kirelate na nung siya sa hyperbolic sine, same sila nun, pero inumanan sa kanya sa variable h para ma-identify tanong a hyperbolic function na to. And second naman is 1 over cosine, diba? And then cosecant is 1 over sine. Kung hyperbolic second function na kumanandus kanya sa h saya, kumanandus kanya sa sine h. Same lang talaga. Yun yung analogy between the trigonometric function and the hyperbolic functions. In theorem 2.8.2, if f of x is equal to the sine h of x or the hyperbolic sine function x, then yung derivative niya is cosine or hyperbolic cosine of x. If f of x naman is equal to the hyperbolic cosine, yung pangalawa, of x, then yung derivative daw niya is sine or hyperbolic sine of x. So, sine, ang derivative niya is cosine. Ang cosine, ang derivative niya is sine. And then, sa tangent, hyperbolic tangent function naman, ang derivative niya is secant squared. Okay, hyperbolic function, hyperbolic secant squared of x. And then, hyperbolic cotangent of x naman, ang derivative niya is the negative cosecant squared or hyperbolic negative cosecant squared of x. And then, si second naman, ang derivative niya sa hyperbolic function is negative secant h of x times the tangent of h of x. Okay. So, kung mapapansin niyo class, doon sa derivatives ng trigonometric function, di ba si sine and cosine sila yung partner, si tangent and cotangent din, and then si cosecant at saka si tangent at saka si secant, and then si cotangent at saka si cosecant din. Pero ang pinagkaibahan dito kasi ang naging derivative ni hyperbolic cosine dito is positive sign. Hindi siya naging negative. Doon kasi sa derivative ng trigonometric function, ang magiging derivative ni sine is negative. Pero dito sa hyperbolic positive. Ang negative lang dito class, ang tandaan nyo lang dito sa hyperbolic, ang negative lang is si cosecant squared at saka si secant x, h, at saka si hyperbolic tangent x, at saka si cosecant, hyperbolic cosecant, at saka si hyperbolic cotangent. So, giyabot ang loading man negatibon. Unlike kasi ro sa derivative of trigonometric function na aya ka-negative roon na. So, basta aya given na function na it starts with letter C. Saya na kanaba. Okay. So, ang formula na gagamitin natin or magagamit natin sa mga examples is ito siya. So, let u be a function of f of x. Then, ang derivative ni hyperbolic sine of u is equal to the hyperbolic cosine of u times derivative of u with respect to x. Basta always sa formula na lagi dip kaswayan. Lagi mambusi ko inverse sa trigonometric function, di ba? Sine inverse of u is equal to the cosine inverse 1 over the square root of 1 minus u squared times derivative of u. So, lagi sirang bu. And then, saya mambu sa ikadua formula na hyperbolic cosine of u is equal to the hyperbolic sine of u times du over dx. Tangent h of u is equal to the second squared of u times d over dx. So, kumbaga nag-Gia theorem na in-summarize kanyang sa formula. The same lang talaga sila. And then, derivative naman, ang d over dx plus ibig sabihin niya derivative of the function x. Ang derivative ni cotangent h of u or the hyperbolic cotangent is negative cosecant squared. Negative cosecant squared du over dx. And then, sa second hyperbolic secant naman is ito siya. Negative secant du tangent h of u du over dx. And then, the same also with the cosecant h negative cosecant of hu times the cotangent of hu du dx. Okay, so let's give an example to apply these formulas. Find the derivative of the following. First is, ang given na function is f of x is equal to cosine h of x squared plus 1 or hyperbolic cosine of h, hyperbolic cosine of x squared plus 1. So, ito yung u natin. Okay. So, lagi puro o ko inverse trigonometric function na kasi so, inverse trigonometric function na since makatatalong din na dito ipag-let u u. Okay, so using formula 2, we let u equals to x squared plus 1 and then get the derivative of u. Ang derivative ng x squared plus 1 is 2x. du over dx plus ibig sabihin niyan derivative of u with respect to x. Kasi diba, ang function natin is u in terms of x. So we have f prime of x kasi f yung ginamit dito. So f prime of x is equal to sine or hyperbolic sine of u times du over dx. So ito yung formula, no? Sa formula 2. So, si sine, bring down tanunan, si sine h, and then si u nasabihan sa x squared plus 1 times derivative ng x squared plus 1 na ginans of 2x, na ginans yung isang ko, du over dx. Or this is just equal to 2x sine h of x squared plus 1. So, ito yung derivative na first example natin. Okay. Another example is g of x equals to cotangent or hyperbolic cotangent of x cubed. So, napakadali. Ang u natin dito is si x cubed. So, using formula 4, we let u is equal to x cubed and then derivative ni x cubed is 3x squared. So, kaya ko diniderive dito agad ay para direct substitution na tayo sa formula. And then, after that, simplification na lang. So, we have replace this one by g prime plus. Sorry, this is g prime kasi g of x yung ginamit. So, this is g prime. Okay, palitan ko lang sa module natin. So, g prime of x is equal to, ito yung formula number 4, negative cosecant squared, hyperbolic cosecant squared, negative hyperbolic of cosecant squared of u times du over dx. So, just bring down negative cosecant squared h and then replace u by x cubed kasi yan yung dilat natin na u. Yan yung function natin. And then, times 3x squared is yan yung du over dx x, or that is the derivative of our u na x cubed. Or, simplify natin, we have g prime of x is equal to negative 3x squared cosecant squared of h times x cubed. Okay, so this is the derivative of example number 2. In this example class, ang given natin na hyperbolic function is the secant. Y is equal to the hyperbolic secant of x squared over e to the power of x. So, ibig sabihin, nag-usarta naman mo siya. So, derivative o exponential function tanong. So, using formula 5, so we let u is equal to x squared, yung sa taas. Okay? So, ang u natin dito is the x squared. And then, ang derivative ni x squared class is 2x. So, using the quotient rule to get the derivative of the given function, kasi ang involved dito na operation is division. So, that's why gagamit tayo dito na quotient rule. So, ang quotient rule is low d high minus high d low over squared, or bu prime minus ub prime over b squared. Okay. So, ang low natin is e to the x, and then ang high natin is, derivative ng high natin is negative secant h of x squared. Diba ang derivative na to using the formula 5? Okay, take note, ginamit si formula 5 dito sa derivative ng function natin sa taas. So, ang derivative niya is negative secant h of x squared times the tangent of h x squared times yung u kasi natin dito na x squared is, ang derivative niya is 2x. So, that's why ito yung derivative ng high function natin or upper function. Okay, minus yung high natin is secant h of x squared times yung derivative ng low natin na e to the power of x pa rin. So, take note sa theorem 2.7.2, derivative of e to the x is e to the x pa rin. Okay, sa denominator, squared lang natin yung nasa denominator natin na e to the x quantity squared. So, simplify natin, magiging negative 2x to the power times e to the power of x secant h x squared tangent h x squared minus, okay, e to the power of x secant h of x squared. Si e to the x quantity squared, that is just equivalent to e to the power of x. Kasi dalawang beses daw tayo magta-times ng e to the x. So, i-add natin yung exponent x plus f, that is equal to x. So, after that, para ma-simplify natin siya in lowest term, factor out natin yung common factor nila. Sa first term, ang common factor ni first term and second term is si e to the power of x, negative, kasi negative din kasi sa first term. So, negative e to the power of x secant h of x squared. So, pwede natin siyang i-factor out kasi meron din to dito sa first term natin. So, ilabas natin yan, kasali si negative. Okay, sali natin si negative. So, magiging, ang may ipa-factor out natin is negative e to the power of x secant h of x squared. So, sa first term, we left with 2 na lang. Saan nilagay si x? Okay, 2x. May x dito class. Sorry. May x dito. Okay, kasi ang na-factor out lang naman is si e to the power of x, diba? So, 2x tangent of h squared plus 1. Okay, 1 na lang kasi yung natira dito sa second term. Kaya, nag-ibumilang ba saya? Sa first term mo muna, ibumilang mo na sa 2x tangent of h x squared. Okay, may x dito. Do not forget kasi nakalimutan kong ilagay. So, negative. So, since si e to the power of x, pwede natin siyang i-divide dito sa denominator natin. So, pwedeng isa na lang yung matira na e to the power of x sa denominator. So, we left with e to the negative secant h of x squared times 2x tangent of h x squared plus 1 e to the power of x. So, this is the derivative of the third example. In fourth example, ang given natin is h of x is equal to the square root of cosecant h of 5x. So, since naka-radical siya, ang rule doon sa theorems on differentiation, pag naka-radical yung given natin na function, convert into exponential function. Okay, so using formula 6 kasi hyperbolic cosecant man. So we let u here as 5x. Okay, kasi ito yung function natin dito. Function ni hyperbolic cosecants, excuse me. So we have we let u is equal to 5x and then derivative of 5x is 5. So note that h of x equals to the square root of cosecant h of 5x is equivalent to the cosecant of h of 5x raised to the power of 1/2. So ito yung exponential form ng given natin. So applying the chain rule and formula 6 respectively to get the derivative of the function. So we have h prime of x is equal to 1/2. Okay, ang derivative na to is, derivative niya is, bring down natin si 1/2, diba? Applying chain rule man daw. Okay, and then after that, saka si formula 6. So 1/2 times the cosecant h of 5x, minus tayo ng 1 sa exponent, so that's why naging negative 1/2 na lang, times, okay, etong part na to class, is, yan yung derivative ng cosecant h natin or hyperbolic cosecant function natin. So, ang derivative na to is negative cosecant h 5x times cotangent x 5x times yung derivative ni 5x na 5. Okay, so chain rule talaga. Okay, so we have h prime of x is equal to negative 5 over 2 because 1/2 times 5 times negative na nandito. Di yan minus ha, kundi times yan kasi may parenthesis man. Okay. May isang parenthesis yan. Ayan. Ayan pa yung ito pala yung partner niya. So, 1/2 times the negative is negative 1/2 times 5 is naging 5 over 2. So, cosecant h 5x, negative 1/2 and then bring down lang din natin to. Cosecant h 5x times cotangent h of 5x. So, we have, so eto para maging positive siya, dinibalik natin into radical form kasi yun naman yung given natin. So, that's why nilagay siya dito sa denominator. And then, ang natira na lang sa numerator is etong part na to. So, eto siya. And then, negative 5 over 2. Si 5, andito siya. And then, si negative, andito. And si 2 is, dito ko nilagay sa denominator. So, that is for the example number 4. In example number 5 class, arctangent. So, inverse combination ng inverse trigonometric function and hyperbolic function. Madali lang to kasi formula lang man. So, applying the formula for the inverse trigonometric function of tangent. So, ang derivative ng inverse trigonometric function ng tangent natin is the arctangent inverse of u is equal to 1 over 1 plus squared times the derivative of u. So, gagamitin natin to para makuha natin yung derivative ni arctan. And then, ilalat natin na u dito is si tangent h of x. Okay. And then, after that, using the formula 3 above, yung sa hyperbolic functions to get the derivative of u. So, we have d over dx. Ang derivative ni tangent h of x is si secant squared of x times 1 kasi ang derivative ng x natin is 1 or this is just equal to secant squared of x. Then, okay, so y prime, apply natin yung formula ni arctangent kasi arctangent man. Nandito, ang given natin na function is arctangent. So, using this formula, so we have 1 over 1 plus, okay, si u dito, replace natin siya by tangent of h of x kasi yan yung u natin, quantity squared times yung derivative ng tangent h of x is si secant squared of x of x and n. Okay, so simplify lang natin. 1 times secant squared of x is secant squared of x. Sorry, may h dito kasi hyperbolic function man. Okay, may h dyan, may h din dito. Kasi hyperbolic function. Kalimutan kong isulat ha, typo error. Okay, so secant squared h of x sa denominator is 1 plus. Okay, eto class, equivalent lang as tangent squared of h times x. So this is the derivative of this given function. Sa formula, sa example 6 rather, is ma-apply natin dito yung implicit differentiation. So, ang given natin is sin h of xy equals to y e to the power of x. So, differentiating both sides of the equation implicitly, so we have, ibig sabihin nun, i-derive natin to implicitly both sides. So, kiplet ano siya, so implicit differentiation, nagito so, kuan so y prime. Okay. Kasi may line yung lagi daya, ay given na lagi daya na implicit differentiation nag-posaryo ron. So, sin h of xy, ang derivative nito class is magiging cosine h or hyperbolic cosine of xy times, okay, yung derivative ng xy natin, okay, kasi diba ito yung u, sin h u man to. So, diba ay derivative o hyperbolic sine function na cosine hu times du man. Okay, so ay u kasi tanong si a na xy man. That's why cosine of xy times jsu na since buti man na variable ang bida, ibig sabihin na involved sa operation na multiplication. So, apply tayo saya. So, i-apply tayo man saya so product rule. So, first times the derivative of the second. Ang first natin is x, derivative ng y is 1. Since variable y yan, magdadagdag tayo ng y prime kasi implicit differentiation man yung i-apply natin dito. Plus, second, ang second function natin is y times yung derivative ng x na 1. Okay. Take note sa implicit differentiation na kapag umaniubo sa y prime na igiraasi ka nung nag-derive kung variable y. Okay, sa right side naman na equation, ang derivative nito is the same pa rin, product rule din. So, y times e to the power of x. So, first, times yung derivative ni e to the x, yung second function natin is e to the x pa rin. Plus, yung second na e to the x, times yung derivative ni y na 1, since i-derive na nung kay y, nakuman ang tanong niya sa y prime, times 1 na y prime. Dagan sa heading tagwa, so 1. Okay, so simplify natin. Ito, distribute natin dito. Okay, so ang mangyayari is ganito. Xy prime times cosine h xy plus y times 1 is y pa rin times cosine h of xy. Sa right side naman is y e to the power of x plus y prime e to the power of x. Okay, and then simplify natin. Lahat ng may y prime na terms is ilagay natin sa left side, and then lahat ng terms na walang y prime is ilagay natin sa right side. So, eto, bring down lang natin, remain siya dito, and then si y prime e to the power of x, lagay natin dito. So, naging negative siya kasi positive man dito, di ba? So, eto din, transpose natin siya sa kabila, and then eto naman is remain lang. And then, after that, pag nakumbay na natin lahat ng may like terms, is factor out natin yung common factor nila. So, ang common factor dito sa first term and second term is the y prime kasi yan man yung goal natin dito, si y prime. So, pag dinanggal natin dito si y prime or pinactor out natin, we left with x cosine h of xy minus e to the power of x na lang. So, as is pa rin yung sa right side. So, divided both sides by x cosine h xy minus e to the power of x. So, we get y prime is y e to the power of x minus y cosine h of xy over x cosine h of xy minus e to the power of x. Okay, so for the last example sa hyperbolic function, masyadong maraming example na binigay ko. So, maintindihan niyo na kung paano ma-apply yung hyperbolic function, yung inverse at saka yung yung exponential and logarithm function. So in example number 7, the same with the example number 6, implicit differentiation yung apply natin dito. Ibig sabihin, differentiate natin siya or derive natin both sides implicitly. So ln of y is equal to x squared tangent h of y. So, implicitly man. So, ang derivative ni ln of y is 1 over y times y prime since nag-derive tayo kay variable y man. So, that's why naging y prime. May y prime dito. Sa right side is apply natin dito yung product rule kasi x squared man ito at saka tangent or hyperbolic of tangent function y. So, first times yung derivative ni tangent h of y is second squared h of y. So, since variable y ay napakamangano saya sa y prime. Kami agre-derive ka naman kasi na sa variable y. Plus, yung second function natin na tangent h, katayas kanyan, times yung derivative ni x squared, that is 2x. Okay, take note, walang nadagdag dito na y prime kasi hindi tayo nag-derive kay variable y. Okay, so bring down lang natin yung sa left side. Simplify natin yung nasa right side. Ganito yung mangyayari. So, ang ginawa ko dito class, diretso ko na before ako nag-times ng y both sides, is ang ginawa ko, nilagay ko na sa left side lahat ng my y prime and then sa right side naman yung walang y prime. So, eto, tinranspose ko na siya dito sa left side rather. So, that's why naging negative x squared y prime second h. Sorry, this is second squared h. Okay, my second squared h dito is equal to 2x. Okay, so eto 2x times tangent h of y. In-arrange ang buhay yan. Okay, so factor out si y prime. So we left with 1 over y na lang. Minus x squared second squared. This is second squared ha. Do not forget. Okay. Second squared of h is equal to 2x tangent of h y. So, derive natin, what I mean is, divide natin siya both sides by 1 over y minus x squared second squared h. May second squared dito, h times y. This is the derivative of. So, that is for the hyperbolic function. Okay, last na talaga class. Last part ng subtopic sa derivative of function, the indeterminate forms and L'Hopital's rule. So, saya sa indeterminate forms sa L'Hopital's rule class na so application no derivative of so limits. Pagkilan nyo si din kasi na, so ibukuan nyo so limit or ipag-evaluate nyo so limit o given na function na it's either kukuha nyo na 0 over 0 o di na infinity over infinity. So, may mga rules tayo or forms sa indeterminate forms. Sa form 1 sa indeterminate forms class, form 1, if nag-evaluate na kayo ng limit, direct substitution, what I mean is, diretso ba, direct substitution, if ang result is 0 over 0, form 1 yan. If ang result is infinity over infinity, form 1 din yan. Sa form 2 naman is, if ang result sa pag-evaluate nyo ng limit by direct substitution or using direct substitution is 0 times infinity is form 2 yan. Or infinity minus infinity, form 2 din yan. And then sa form 3 naman is, ang result is yan, if ang given natin na function is exponential, so 0 raised to 0, or infinity raised to 0, or 1 raised to the power of infinity. Form 3 yan. So, ito yung mga forms ng indeterminate. In theorem 2.9.1, that is what we call the L'Hopital's rule. Suppose the functions f and g are differentiable at every number except possibly at c in an interval ab, open interval ab to g prime of x not equal to 0 for x not equals to c, and if the limit, okay, so take note, may limit tayo dito. Ito yung first topic natin before tayo proceed sa differentiation or derivative of the function. If limit of f of x divided by g of x as x approaches c has indeterminate form 0 over 0, infinity or over infinity, then, okay, ito yung form 1. Okay. Then, the limit of f of x over the g of approaches C is equal to the limit of f prime of x divided by the g prime of x as x approaches C. Okay, provided that the limit of f prime of x over the g prime of x as x approaches C exists or becomes infinity. Okay, so let's give an example para malaman natin or paano natin ma-apply yung L'Hopital's rule or at saka yung indeterminate forms. Evaluate the following limits. Okay, first example class, the limit of x squared minus x minus 6 over 2x squared plus 3x minus 27 as x approaches 3. So, para malaman natin kung anong, saan siya doon sa form 1 is, i-evaluate natin itong limit natin using direct substitution. Ibig sabihin nun na, si tano saya na substitute tano saya diretso sa giya function tano na pagiling tano kukuha tano result na it's either 0 over 0 or infinity over infinity nagutan na rum apply so L'Hopital's rule. So using direct substitution first to evaluate the function if it satisfies the theorem 2.9.1. So kung si 3 na i-direct substitution tano saya or i-direct substitute tano si na di ba y plus y na 3 squared minus 3 minus 6 na di ba 0 kasi na 9 minus 3 is 6 minus 6 0 and then sa denominator naman 2 times 3 squared is 2 times 9 18 plus 9 minus 27 is 0 pa rin yan kasi 18 plus 9 is 27 minus 27 0 pa rin. So nagsatisfy siya doon sa theorem 2.9.1 or that is what we call the L'Hopital's rule. So, para daw makuha natin yung limit nito na or mapa-exist natin yung limit niya, gagamitin natin yung L'Hopital's rule. So, yung L'Hopital's rule na yung class is eto siya. Kukunin daw natin yung limit ng derivative ng function natin sa taas at saka yung derivative ng function natin sa denominator as x approaches C. So, we have the limit of 2x minus 1. Saan kinuha si 2x minus 1? Yan yung derivative ni x squared minus x minus 6. Diba derivative ni x squared is 2x? Derivative ni x is 1. And then, derivative ni 6 is 0 kasi so hindi ko na nilagay dito si 0. And then also, si 4x plus 3 class is yan yung derivative ni 2x squared plus 3x minus 27. So, derivative ni 2x squared is 4x. And then, derivative ni 3x is 3. So, ibig sabihin nun class, ang purpose ng L'Hopital's rule is, if mag-evaluate na tayo ng limit, kapag ang lumabas na 0, by direct substitution class, and then pag yung lumabas na result is, it's either 0 over 0 or yung sa form 1, infinity over infinity, ibig sabihin nun na, itusok tayo makapag-apply nyo yung L'Hopital's rule. Ibig sabihin nun na, derive niyo so numerator yung gusto denominator. And then after that na, ipag-evaluate yung man. Na man no, kasi man sa 0 over 0, di na infinity over infinity. Pag-derive ka naman, tama sa di mag-exist. So, answer yan. Or so, result yan na define. So, since ito yung derivative ng numerator and denominator natin, pwede na tayo mag-evaluate. So, 2 times 3, si 3, substitute natin dito. So, 2 times 3, that is 6, and then minus 1, that is equal to 5, diba? And then 4 times 3, that is 12, minus 3, that is 9. So, 5 over 9. So, since nag-exist naman, eto na yung magiging final answer natin. So, mag-stop na tayo dito. Okay? So, that is for the application of the theorem 2.9.1 or the L'Hopital's rule. Sa next example natin class is, dalawang beses natin i-apply yung L'Hopital's rule. Sa example number 2, parehas pa rin ng given, no? Mapapansin niyo, given natin ang function is the same lang, but yung c natin dito is infinity na siya. Kanina kasi sa example number 1 is defined. Real number siya na 3. Okay, so the same process, use direct substitution first to evaluate the function, and then if it satisfies the L'Hopital's rule, a theorem of L'Hopital's rule, saka natin siya ma-apply. Saka natin i-apply or gamitin yung L'Hopital's rule. So, we have the limit of x squared minus x minus 6 by 2x squared plus 3x minus 27 as x approaches infinity. So, di ba kahit anong, pag sinubstitute na natin to dito, yung infinity na yan, so infinity squared is infinity pa rin. Minus infinity, infinity pa rin. Minus 6, infinity pa rin yung result, di ba? Kasi mas malaki man yung value ni infinity compare kay 6. So, the same with the denominator, 2 times the infinity squared is infinity, plus 3 times infinity, infinity pa rin, minus 27, ang result is infinity pa rin. So, nag-satisfy yung result natin sa theorem 2.9.1 sa form 1. Kasi diba ang sabi doon, if yung limit daw natin is it's either 0 over 0 or infinity over infinity. Pag nag-satisfy, ibig sabihin, i-apply na natin yung L'Hopital's rule. So, ito yung tinatawag natin, or ito yung sinasabi kong L'Hopital's rule. Ibig sabihin lang nun, i-derive natin yung numerator, i-derive din natin yung denominator. Saka tayo mag-i-evaluate. Okay, so ang derivative ni x squared minus x minus 6 is 2x minus 1. The same lang doon sa first example. And then derivative din ni 2x squared plus 3x minus 27 is 4x plus 3. So kung i-evaluate natin, 2 times infinity is infinity pa rin, minus 1, infinity pa rin yung lalabas. 4 times infinity naman is infinity plus 3, infinity pa rin. So diba, hindi pa rin nag-exist yung limit niya. So ibig sabihin ng class, apply tayo ulit ng apply natin ulit yung theorem 2.9.1 or the L'Hopital's rule. Ibig sabihin, derive ng tanok mane pero man, derive ng tanok mane pero man. Okay, so we have the limit of the derivative of 2x minus 1 is 2, diba? 2x, derivative niya is 2. Derivative of 1 is 0 naman. So, hindi ko na nilagay si 0 kasi 2 minus 0 is 2. 2 pa rin yung lalabas na result. And then, derivative ni 4x plus 3 is 4. So, sa limit, theorems on limit, kapag ang given na function is constant, ang limit niya is the constant. So, that's why, ang limit ni 2 over 4 as x approaches positive infinity or infinity is 2 over 4. So, since nag-exist na yung limit ng function natin, mag-stop na tayo dito. Okay. So, giveaway tayo ginurod. So, L'Hopital's rule, nag-i-apply nyo huskan niya na ibarat ko si kaya direct sa i-evaluate nyo ko function niyo na ayam niya kwan yung result na is either 0 over 0 o di na infinity over infinity na kung nyo rin mag-i-apply sa L'Hopital's rule. Ayap hindi nyo ron, nan-derive nyo sa numerator yo and then derive nyo man so denominator. Tapos, pag-evaluate nyo man. Ibarat ko ayap man yung result na lagi diyang book na ba-define na pag-apply nyo rin man paruman so L'Hopital's rule. Derive ka naman, taman sa di continue makwaso, mapa-exist your result yan, define. Okay, so yun yung purpose na L'Hopital's rule. In this example class, ang given natin is a trigonometric function, the limit of sine 3x over x as x approaches 0. So the same process pa rin sa example 1 and 2, use direct substitution first to evaluate the function. And then, if mag-satisfy siya sa theorem 2.9.1, apply natin yung theorem na yun. So, we have the limit of 3x over s as x approaches 0. So, diba, sine of 3 times 0. So, sine of 3 times 0. 3 times 0 is 0. Ang sine ng 0 class is 0, diba? And then, replace natin si x by 0 is 0 pa rin. So, nag-satisfy siya doon sa theorem 2.9.1. And then, apply natin yung theorem na yan, the L'Hopital's rule. So, ibig sabihin, i-derive natin yung numerator, i-derive din natin yung denominator. So, ang derivative ni sine 3x class is cosine 3x times yung derivative ni 3x na 3. So, that's why naging 3 cosine 3x. Derivative ni x is 1. Okay. So, i-evaluate natin. So, we have 3 times the cosine of 3 times 0. Replace x by 0. And then sa denominator is 1 pa rin yan. Okay, cosine of 3 times 0 is cosine of 0 ito. So, ang cosine of 0 plus is equal to 1 man, diba? So, 3 times 1 is 3 over 1. So, 3 divided by 1 is equal to 3. Okay, so isang beses lang tayo nag-apply ng L'Hopital's rule. So, yan yung example natin sa indeterminate forms and L'Hopital's rule. Take note class, use L'Hopital's rule in evaluating limits by direct substitution which resulted to indeterminate form 1. Okay, so ang sabi niya dito, gagamitin niyo lang daw yung L'Hopital's rule in evaluating limits by direct substitution which is resulted in indeterminate form 1. So ang pag binyan sa indeterminate form 1 na dito sa 0 over 0 o di na infinity over infinity. Sa kanyo rukun closer, so L'Hopital's rule. Indeterminate form 2 naman can be expressed into that form of form 1. So, pwedeng yung indeterminate form 2 na kapais kanyan ma-express in form 1. In indeterminate form 3 naman are results from expressions of the form h of x is equal to f of x raised to the power of g of x and can be changed to either form 1 or form 2 by making use of the logarithm. So we have the following steps here to consider. So let y is equal to f of x equals to g of x, and then the second step is take logarithms or ln both sides and simplify. So the rest of steps is equal logarithmic differentiation of logarithmic function, and then apply natin yung logarithm log of m to the power of r with the base a is equal to r times the log of m with the base a, and then after that find the limit ln of y as x approaches a if it exists, and then the last step is if the limit of ln of y as x approaches a is equal to l or defined siya, then the limit of y as x approaches a is equal to the limit of f of x raised to the power g of x as x approaches a, or that is equal to e to the power of l. Okay, so thank you. So yan lang yung topics or subtopics sa different derivatives of the function. So I hope na may maintindihan tayo sa lecture na to or sa topic na to, kasi pag hindi ninyo na master yung derivatives of a function or differentiation class, is mahirapan kayo doon sa calculus ninyo. Okay? Good luck!